Hello, everyone. So good to be here. So today I'll be talking to you about harnessing our platform, which is called Memory Machine Cloud, or MMCloud, for efficient Nextflow pipelines and tapping into cost-effective and dynamic resource management. We all love Nextflow because of its scalability. Nextflow was designed from ground up so that you can run it on your laptops, on HPC clusters, and on the cloud with a simple change of configuration. And this is possible because of the decoupling of the configuration that Nextflow allows for. And currently, the platform Sequera supports different cloud providers, right? So you have AWS Batch, Azure, and Google Cloud. So for people who are still not using cloud, I've just listed out some of the chief advantages and disadvantages of cloud here. You can see, so the chief advantages of the cloud is that you pay for what you use, and also you don't have to maintain or own these resources, so it's not your problem. You just pay for the service. But with these convenience, there are also disadvantages that come along with it, is that there's a lot of wasted cloud resources, and we just heard from Sabrina and just bringing about the awareness about our carbon footprint of our pipeline runs. Running jobs on cloud can become quite expensive very fast with some unforeseen compute. You left some pipelines running that can add up and cost you a lot. You have long-running jobs at the risk of disruption. And there's a steep learning curve for adopting the cloud, so it's not a simple drop-in replacement as well. So with these, also for people who are not familiar with the cloud offerings, you have two different kinds of instances that the cloud providers offer. Those are the on-demand instances versus spot instances. So on-demand instances are you pay a fixed price for a guaranteed service, whereas with the spot instances, you have these hyperscale cloud providers auctioning off their excess capacity at a fraction of the price, and usually these discounts range between 50 to 90%. So we just launched a tool on our platform, and we call that the WaveRider, where you can clearly see the difference between the current pricing estimates of on-demand and spot instances. So the dilemma here is, do you opt for a stress-free premium of guaranteed on-demand instances, or do you take or play the gamble with spot instances? Sorry, I forgot to mention the spot instances, which are cheaper, come with a catch. They can be taken back by the cloud providers on a very short notice, usually 2 minutes in case of AWS. So do you want to pay more for the on-demand instances, or do you opt for spot instances but handle that they can be taken back by the cloud providers at any time? So it's always this dilemma, but managing costs is a big issue when you are running your workloads on the cloud. Currently, Nextflow allows for these error handling mechanisms. By default, if you're running on spot instances, Nextflow has a spot retry attempt parameter that is defaults to 5 times. It'll try for different spot instances before the task fails. But the essential point here is that if a spot instance is reclaimed, the Nextflow is basically going to rerun your entire job. So imagine if you had an alignment job that was almost finishing, and there was a spot reclaim, and essentially it's going to retry and start the job from all over again. So considering the carbon emissions, it's a waste of time, it's a waste of resources, and also not friendly to the environment as well. Also, not only just spot reclamations, we all have seen processes where they fail due to insufficient resources. They're running out of memory, or the CPU utilization, CPU cores aren't enough. But Nextflow also has dynamic retry strategies, right? So where you can set the amount of resources that it needs to retry again based on the task.attempt. But this is, again, essentially, it just adds up to your cost, because if the instance has been reclaimed, on the next task attempt, you are basically asking for double the resources, which is like twice the cost. So it quickly adds up when you consider if you're using these cheaper instances, but every time it's just adding up to your costs. So with that, we would like to introduce our platform. It's called the Memory Machine Cloud. It's basically a container orchestration platform for running data-intensive workloads and also an interactive applications on the cloud. Currently, we support AWS, Google Cloud, and also Ali Cloud and Baidu Cloud on the Chinese market. So to dive into what are the features that are available on the platform, we essentially provide a CLI to interact with the cloud. So we call this the Float. Float is the CLI and also a job management service. So with this CLI, you can submit jobs to the cloud, track them, manage all these resources through the CLI. Also, we have something that's not currently available on AWS Batch and also on Platform Secure at the moment is real-time monitoring of CPU and memory usage. So you can clearly see the CPU and memory usage of a particular job in real time using the WaveWatcher profiles, and also carbon footprint. So we are not providing on a granular level that Sabrina has shown along with the NFCO2 footprint plugin, but we do track them on a workload basis, on a higher level basis. So offer these WaveWatcher profiles. So the core service that we are offering is what we call as the Spot Surfer. So this is basically, just to take an example, imagine you have a pipeline running, say RNA-seq. I have a job up shown up there. It's called the QualiMap. It's one of the processes in RNA-seq. So what you're seeing here is the memory usage. And it's almost, as the graph shows, imagine it's almost finishing up and a spot reclamation has happened. So now coming to the secret sauce that Memory Machine Cloud offers is that whenever a spot reclamation or a spot interruption notice is provided, we can take a snapshot, freeze the container, take a snapshot of the application that's running, move it to another new instance, and restore the application on a new instance. So in this way, essentially, you are not losing your progress. In the application's perspective, nothing has happened. And in this way, you don't have to rerun the entire job again. So in this way, you can take the advantage of running on cheaper spot instances, also have the insurance that you won't lose your progress of your workflows, even though a spot reclamation happens. And you can see all these. We also have a user interface, but you can also monitor these via the CLI too. There are some exceptions, though, like when you have really large memory-intensive applications. Usually, the 2-minute warning that the cloud service providers provide might not be enough to dump everything that's in memory onto disk. So what we are coming up with is incremental snapshots that will be where periodically snapshots will be taken of your application so that you don't lose your entire progress and you don't have to restart from the beginning. Also, with this function, another feature that we offer is what we call as the WaveRider. So with this, you can dynamically right-size your instances in real time. So this is because we are monitoring the CPU and memory usage in real time, imagine if an application is ever running out of memory, we can take that as a trigger, freeze the application, snapshot it, and move it to another instance. So what you're seeing here is an application where it started off on a 4 GB machine, and it was running out of memory. So the application was frozen, and then the next bigger instance is found and is deployed onto that instance, and it continues. Again, you can see as it starts hitting the upper limits of the resources that are available, the migration mechanism is kicked in, and it'll dynamically move your workload onto an instance that is a right fit for the workload. And the converse is also true. If your application is not utilizing all the resources that are available on a machine, you can configure to make sure that it can migrate to an instance, a smaller instance, where it will be able to finish the workload there. So in this manner, you can make sure you're providing just the right resources for your workloads. And I believe this is in the interest of also raising more awareness about the carbon footprints of our jobs, because raising awareness is one step, but what are we going to do about it? So this is one way where you can make sure you are using just or getting the right resources that are required for your workloads. How do we connect with Nextflow? So we have developed a plugin. We call this the NF-Float plugin. And with this plugin, you'll be able to add on a simple configuration changes to your Nextflow pipelines. So as you can see, you just need to specify the plugin, the work directory, an S3 bucket, and provide your credentials. And all the jobs will be now routed to MMCloud. So it's basically a replacement for AWS batch service. While MMCloud is handling, by default, all the jobs that will be checkpointed will have the insurance of checkpointing and restore, and also being able to select different types of VMs, be it spot or on demand. So the two main features I want to talk about are that you can set, mix and match, or set individual VM policies to your individual process as well, using the with name selectors in Nextflow, right? So if you really have a job that, a huge job that you really can't afford on a spot instance, you can make sure that that particular job runs on an on-demand instance, while the rest of your workflow runs on spot instances, essentially giving you the mix and match configuration advantage. And also, as you can see here, for what I have in the second process, you can set the migration policies, really fine-tune your migration policies, where you can set the upper bound and lower bound utilization parameters for CPU and memory utilization, and set those either by default for the entire workflow, or you can also customize it for individual processes within the workflow as well. So just to provide a high-level overview with the plugin, the way we are deployed right now today is through AWS Marketplace. The operations center of MMCloud will be deployed on an instance within your VPC, and all you need from there on is the additional config specifying the plugin that I just showed you, and also as you can see, once you have the plugin and the operations center set up within your VPC, all the jobs, the operations center will take care of spinning up the worker nodes, finding based on the user policies, VM policies that you set, the operations center will take it on from there. So because we are deploying within your VPC, data privacy is built in, so there's no sharing of the data essentially with the outer world. So now I want to talk to you about extending MMCloud capabilities further with different file systems. So this is something that we have been working with Sequera, is genomic applications essentially are, or let me put it this way, cloud is not essentially the best platform for running genomic applications, which can produce gigabytes to terabytes of data, because these are stateful applications. So And you must all have seen the breakthrough fusion report that was put out by Sequera, where you can clearly see that the fusion file system has offered a more optimized and more highly performance-driven alternative for the current existing file systems that are available. So what we are trying to do is also extend this capability with Memory Machine Cloud. So currently we support 3 different file systems, the default S3FS, FusionFS, and JuiceFS. Currently, the checkpointing and restore software or feature of MMCloud works only with S3FS and JuiceFS. We are currently trying to get it to work with Fusion. So hopefully we can, once we have that working, we can integrate directly into platform Sequera. And because from the perspective of all these 3 different file systems, Fusion file system is the most efficient and also the least resistance that requires the least amount of setup when compared to the other 2 file systems. So I just want to show some comparison between a recent benchmark study that we have done comparing AWS Batch versus MemCloud. So what you're seeing here in blue is AWS Batch, and in orange is MemCloud. And we ran the NF-core RNA-seq using the testful profile on using the full-size test dataset. And you can see clearly MMCloud outperforms AWS Batch in terms of wall time, CPU time, and also in cost. So what you're seeing here in the third graph is comparing on-demand versus spot instances. So if it costs you $97 on AWS Batch for using on-demand instances, the same if data set that is the same pipeline, if you run it on MMCloud using JuiceFS or Fusion, it costs you a fraction of what you would be paying for the on-demand instances. So we believe this is highly crucial where so that you don't rerun, so that you can make sure you utilize these cheaper instances, but also have the guarantee that you won't lose your work while we are performing our computations. So with that, I would like to acknowledge the Sequera team, especially Ben for helping with the plugin, Jody for helping with the Fusion integration, and Paulo for all the discussion and encouragement on bringing this platform into the Sequera community. And of course, for all these awesome pipelines that we use every day. And also, I would like to acknowledge the core developer team from MemVerge for their hard work on bringing some innovative features so that you can interact with the cloud via CLI and also the plugin. With that, find us on Nextflow Slack. We have a channel called Platform MemVerge. Drop in there, and we can chat more. Thank you so much for your attention.
Thank you, Sateesh. We have a few questions here, but maybe we'll go for one and then break for lunch. Do you know if this approach would be transferable to GCP's preemptible instances?
I'm sorry, could you repeat that again?
Would this approach be transferable to GCP's preemptible instances, which are similar to the spot ones?
Yes. We do support preemptible instances on GCP. So the issue with GCP is on AWS, you get a 2-minute warning for spot preemption, but GCP is not so kind enough. Usually it's 30 seconds or less. So that's exactly why we are bringing up the incremental snapshot support, where you can set a periodic snapshot interval timer that will take incremental snapshots so that you don't lose the entire progress. You'll lose some, but that's a better trade-off in our view.
Great, thank you. The rest of the questions are in Slack for you.